Systems of linear inequalities. Solve by graphing, and we're given two inequalities, both in slope-intercept form. So let's use the y-intercept and the slope. We'll use a dashed line, and because the top inequality is greater than, we'll shade above that line. Now to shade the bottom inequality, we'll start with 4 for the y-intercept. The slope is 3. It's a solid line, and because it's less than or equal to, it's everything below that line. Now the purple region, which is the overlap of the two regions, that's the solution to this system of inequality. Any ordered pair that lies in this region is a solution. -1, 1 is a solution because it's on a solid boundary line. But this point, which is 0, -3, it's not a solution because it's on a dotted boundary line. For an ordered pair to be a solution, it has to satisfy both inequalities. Here's our next example. Y is less than 4. This is a horizontal line and everything below that. We'll rewrite our second inequality in slope-intercept form, and we'll graph that with a dotted line and everything above that line. The overlap is the solution to the system of inequalities. Any ordered pair that lies in this region satisfies both of them and is a solution. Any ordered pair that does not lie in the overlapped region is not a solution. Also, this point that lies on a dotted boundary line is not a solution. -3, 0 is not a solution. Next example, we're going to solve by graphing, and here we have two lines in slope-intercept form. We'll do the dashed line and everything above it. For the bottom inequality, 4 is the y-intercept, the slope is -1/5, solid line and everything below it because it's less than or equal to. And that dark blue region is the solution region. Any point in that region is a solution to the system of inequalities. Any point outside that region is not a solution. Here we have two lines with the same slope but different y-intercepts. The top inequality is going to be a solid line because it's less than everything below that line. The other inequality is solid because it's greater than or equal to. We want everything above that line. Solutions of this system of inequality would lie in both regions. There is no solution, no ordered pairs exist that satisfy both inequalities. Here's a similar example with the same lines but just different inequality symbols. The top one, because it's greater than or equal to, we want everything above that line. The bottom inequality is less than or equal to, it's everything below that line. Can you see where the two solution regions overlap? That middle section, that is the solution region. Any point that lies in this region is a solution to the system of inequalities. A point that lies outside is not a solution. One more time, in order for a point to be a solution of a system of inequalities, it has to satisfy both of them. It has to lie in the solution regions of both. Okay, similar, where we have our y is greater than or equal to, that's everything above that line. And here is the second line with the y-intercept of 3. We're shading above this line. So the solution region is in the dark blue. Any point that lies in that region is a solution to this system of inequalities. If it does not lie in the dark blue region, it is not a solution to the system of inequalities.